Hello mathematicians, puzzlers, and other curious people. In this video we're going to take a look at multiplying more general pairs of polynomials. And the example that I've got here is x squared minus 4x plus 3 times 2x squared plus 4x minus 5. So going off of what we figured out from the other one, it works best if you put parentheses around each thing you're multiplying, each polynomial, because, that way it kind of organizes up all the things that need to be multiplied by each other. So what we're looking at here really is the product of, in parentheses, x squared minus 4x plus 3 and 2x squared plus 4x minus 5. Now it can be important to know how to set that up because sometimes a problem would give you this verbal format, or sometimes it would give you this right here. So you might get either as your problem statement. Okay, so going off of what we did last time, what we would do is basically take this first factor and distribute it onto the three terms of the other. So what we'd have is x squared minus 4x plus 3 times 2x squared plus the same thing times 4x minus the same thing times 5. And then we'll need to reverse the process. So the 2x squared gets distributed onto those, the 4x gets distributed onto those, and the 5 gets distributed onto those, being careful to make sure that we also switch the signs. Okay, and this is starting to look a problem, right? It's looking pretty difficult now. We could get through it if we really needed to do it this way, but here's the key idea that we can notice to find an easier way. So each term of this polynomial ends up getting multiplied by each term of that polynomial. So there's an easier way we can write this out. So I'm going to just pick the first one, it actually doesn't matter, and use it written just horizontally like it was there. X squared minus 4x plus 3, a little more spaced out. Now I'm going to take the other one and write it vertically over in this area next to that. And so we'll have 2x squared plus 4x minus 5. What I'm going to do with these things, these terms, is use them as row and column headers. So then if I go across here, I'm going to fill in these spaces with the product of their row and column header. So like here, I'll write 2x to the 4th by multiplying these together. Here I'll write negative 8x cubed from that and that. And here I'll write 6x squared from that and that. Now I'd like you to notice that that's the exact same thing that I would have done here. I would have gotten 2x to the 4th minus 8x cubed plus 6x squared. So it's just a little something to save on copying and recopying and having to keep track. So then I'll just continue. So I'll have 4x cubed minus 16x squared plus 12x minus 5x squared plus 20x minus 15. Now this next thing doesn't happen 100% of the time, but it's pretty consistent when you have both polynomials in descending order and they're descending by the same degree. We've got our like terms on the diagonals. And that makes it pretty nice for combining your like terms afterward. So we've got 2x to the 4th minus 8 plus 4, so minus 4x cubed in all, Let's see, -5 and -16 is -21 and 6. Okay, there's an easier way. -16 and 6 is -10, and -5 would be -15 x squared, plus 32x minus 15, and that would be my final answer. So this grid method or box method for multiplying polynomials can make them much easier, and I definitely recommend it when you need to multiply polynomials efficiently.